Good morning and good evening, everyone. Welcome in Salesforce FXR. My name is Amit Chaudhary, and today we are going to talk about the trigger framework. And today our speaker is Adam, who is going to share his knowledge on trigger framework. So let me hand over to Adam.
All right, thanks, Amit. So some statistics about Amit. So thank you all for joining Apex Hours this morning. So as Amit said, my name is Adam Olshansky. I'm a Salesforce developer at YouTube. I have over 500 Trailhead badges and 14 Salesforce certifications, but I'm really passionate about helping people learn on the Salesforce platform, development specifically. I volunteer with Rad Women, which is a program to help female Salesforce admins become familiar with the development side of the platform. And presented at Dreamforce a few times, and very, very excited to be here with you this morning. Feel free to follow me on Twitter at Adam17AMO. I also have a blog you can check out, adam2architect.com. And if you are still have not migrated over to Lightning Experience yet and are looking for some tips, I think Pluralsight has made all of their courses free for the weekend. So feel free to check out my course on Pluralsight at bit.ly/lightning migration. With that, let's get into our content for the day. So today we're going to be talking about trigger frameworks. We're going to start a few steps back and talk about triggers in general. And then we're going to kind of take one step forward and talk about trigger handlers and eventually get into trigger frameworks. I'm going to go over 3 different types of frameworks, 3 different examples. We'll see some code and walk through what those are doing. And talk about kind of how they work and how you can use them. I should do some comparisons between all 3 of them. Talk about some maybe drawbacks, things to consider when using trigger frameworks. And then we're going to do a summary and wrap up. So with that, let's get into it. So I wanted to start a little bit by talking about Apex triggers in general, just kind of to level set here. So as many of you may know, as database triggers in general are kind of automated responses to database events. And so when we're talking about Salesforce platform, obviously the database is going to be Salesforce. And so we can have triggers that fire on any number of database events. So when some activity is happening, some sort of save operation, such as an insert, an update, a delete, or you can undelete, you bring something back from the recycle bin. And we can also have these triggers set to fire either right before or right after the record save operation. So kind of for inserts, that'll be when the record gets its ID. For updates, it'll be after some of the initial validations and things like that, but before some of the post-processing like workflow and email and stuff like that. So that's what we're going to be focusing on, how to kind of control that and make your lives a little bit easier. As I mentioned, Apex triggers take place in Apex code, and they can be on just about any object. So that, for the most part, gives you a lot of flexibility. I think all custom objects, and with the exception of a few standard objects, you can have code set to run pretty much any save operation in the Salesforce org in general. So I'm not going to spend too much time on this slide, but this is just a list of the order of operations that happen when you initiate that save operation on Salesforce. And so the kind of steps we're going to be looking at are steps 5 and steps 19. So that'll be our before and after triggers. So right before a record is actually saved to the database, but after the validation. And then after the record save, but before all of the assignment rules, processes, flows, and the other things you have as well. As you can imagine, with so many different operations happening that can potentially trigger other updates, very easy to get into some sort of recursive state. And so we're going to take a look at how to potentially prevent some of those things as well. All right, and then the last thing I wanted to talk about that we're going to be kind of demonstrating and assuming today is the concept of one trigger per object. So you may already be familiar with this kind of best practice. You may have put it into place for Process Builder as well. But essentially, this is just the notion that if you can technically create 5 different triggers on the account object, but you don't have any way to control which one's going to fire first. And so you'll end up creating some sort of race condition. And so for one user, you might have a situation where trigger 2 fires first and then trigger 4. Another user is going to have trigger 3 fire first, then trigger 1. And every user is going to have a slightly different experience. And that's never really a great state to be in as a developer. It makes debugging very difficult and frustrating for everybody. And so with one trigger per object, you can not only control the order that your code is firing in, but you also have a single place to start debugging triggers. So if something goes wrong, you don't have to go to 5 different places and try to guess which one was causing the problem. You can always start from a single trigger and work on from there. It also makes it very easier to toggle trigger behavior. So if you want to shut down some triggers for an object, either permanently or temporarily, having one trigger is obviously much easier to stop than having 3 or 4. All right, and so I'm just going to go through kind of a basic trigger example here really quick. So let me try to zoom in a little bit. This trigger's not doing anything too crazy, but essentially all I'm doing is I have a trigger on lead here. We're just going to operate on before insert for now. And all I'm doing is essentially looping through the triggers, collecting all the company names, and then trying to figure out, do I have any existing accounts in my org that correspond to these lead companies that I'm inserting? And if any of the lead company names match my existing account names, I want to go create a case for that. So it touches a couple different objects, and we also see this idea that a process that started with a lead being inserted can end up with a different object, in this case, cases being inserted. So the trigger itself isn't too important right now, but just keep in mind this is a single operation for a single trigger just before insert, and it's touching several different objects. So we'll see how that comes into play in a little bit. And we'll see how we're going to change this trigger to make it a little bit better for us to expand on long term. Yeah. And so inevitably, with our triggers, we saw before insert, and that was about 30 lines for our leads, and that was fine, but that could end up growing at some point. We might have some more before insert functionality we want to add. And we may also have different event types we want to tackle, be that after insert, before update, after update, etc. And as we kind of grow our trigger, we may start to find we need to reuse code in a couple different instances. So maybe before insert and before update has some common code that need to run for each one. And if we keep it in our trigger, we basically have to write all of that code twice and test all of that code twice, which is never great from a development perspective. The other thing we're going to end up with is a very long and a potentially very complex trigger that we're not able to test its unique pieces, right? Because triggers can't really have methods in them. You essentially would have to test the trigger all at once. And that's not really a place you want to be in. The other thing is if there's something you need to debug and you now have to go in through that potentially couple 100-line trigger and figure out where exactly a problem is happening. Also not necessarily something you want to be spending your time doing. So how do we kind of get around some of these problems? And for that, we're going to turn to trigger handlers. And so a trigger handler is essentially an Apex class that is going to be handling your trigger logic for you. It's going to allow our code to be called from either other code or from tests in addition to the trigger, so we can have discrete methods that we can unit test much easier. And we're going to be using specific trigger contexts and trigger variables to do our routing, to kind of control what event fires which part of our trigger handler. And the ultimate goal of this handler, there's a couple of them. Number one, we want to keep our triggers as simple as possible because they have the most amount of restrictions and what we can and can't do in them. So it's going to give us greater flexibility in terms of code reuse and testing capability. And as I mentioned, also it's going to make our unit test much, much easier to figure out where a potential problem might be and how we can debug and potentially solve it. All right, so let's see what our trigger looks like if we move it over to a trigger handler now. So I'm going to go back to our code here, and I'm going to open up our lead trigger handler. And all I've done here is essentially moved all that code we had in our lead trigger to a new handle before insert method in our trigger handler class. So it does the same thing. It checks our leads, checks it against the accounts, and if any lead company names match the account names, we'll go insert some cases. And we're going to end up passing in a list of leads, which will be our trigger.new variable. And we're not using them right now, but we have methods in here to handle all the other conditions should we add them later. And then if I go back to our lead here, I can comment out the original code that was 30 lines long, but we moved it all to our handler. So now I can comment out our new trigger code. And it's still going to be a decent number of lines long, but each piece is essentially just going to be repetitive. So basically, we're just going to say, okay, if the trigger is before and the trigger is insert, call our handler before insert method. If it's after insert, call handle after insert, and so on. And so now we're able to handle all the events, and our trigger code is really not going to ever have to get any bigger or messier beyond this. And being able to move it to the handler, already we're seeing some potential benefits. We can test it easier, we can potentially reuse code, and our trigger is going to be a lot simpler than it potentially would have been before. All right, so trigger's good, trigger handler's good. Let's go into trigger frameworks though. So one thing we may have seen right away with the trigger handlers is we still have a lot of duplicated code. So in every trigger, I'm still going to have, if trigger is before and trigger is insert, call my handler before insert. If my trigger is after and trigger is insert, call my handle after insert. And then in our trigger handler itself, we're going to have to put all the different methods either at the beginning to make sure we don't accidentally call a method that doesn't exist, or we're going to have to end up constantly adding new methods to our handler and updating our trigger, which ideally we wouldn't want to do. But either way, we're going to end up with a lot of duplicated code or a lot of unused code or both. And so the question kind of becomes, how do we simplify things? How can we make things better? And how can we make our process repeatable so we don't have to have a bunch of pretty much the same code in every single trigger? And that's kind of where trigger frameworks come into play. So when I talk about trigger frameworks, we're talking about this notion that we want to have generic code that can be extended for any object. We want to make sure that our triggers are consistently handled and that only the code that's really required is needed. And what it's going to give us is very, very simple triggers and simple trigger handlers. And it's also going to handle all the routing for us. So we don't have to put is before is insert, is after is insert, is before is update in every single one of our triggers, potentially making a mistake and causing a problem down the road. The framework's going to handle all of that routing for us. And we can just really focus on the interesting parts of the code, the business logic, and the stuff that's going to be giving real value to the stakeholders. The other thing that the framework will do is it's going to ensure and enforce consistent trigger behavior. So I'm not going to have to worry when I'm debugging, does the account trigger work differently than the lead trigger? I'm going to rest assured it's all using the same framework, and therefore it's all going to be behaving the same. I don't necessarily even have to look at the trigger code to figure out how the routing is working, what conditions are happening. I can be pretty confident that I can go straight to skipping a few steps and going into the logic directly, because I know the framework's going to handle everything before that for me. The other thing the frameworks are going to do is generally we can put in a way to allow for some sort of trigger bypass. A couple different ways to do that, as we'll demonstrate. But basically some way to have some sort of recursion check. We want to make sure that, number one, our triggers aren't firing multiple times in the same transaction. We want to make sure that our triggers aren't firing in one instance while they're in the middle of finishing up another instance. And we want to potentially have a way to turn them off or disable them from running at all. And the last thing we're going to want to be able to do is potentially have different behavior for triggers that start a process versus triggers that kick off in the middle of a process. So if you saw the trigger that we talked about at the beginning, we saw the operation was about inserting leads, and we ended up inserting some cases, which is going to fire the case triggers. And so the question becomes, do I want those cases to follow all the same logic as they would if I was creating a new case in the UI? Maybe I do, maybe I don't. Same question if I am inserting some leads and I insert some cases, which then fire another process that inserts some more leads. Because I'm already in a lead insert operation, do I want those subsequent leads to follow the same process, or do I want to do maybe something different with them or skip processing altogether? So the framework is generally going to give us some sort of way to allow us to handle that and force the code to run through different behavior if it makes sense for us to do at the time. All right. So it's great. We talked about triggers, we talked about trigger handlers, and we talked about trigger frameworks. Let's go into a couple different options of how this looks in practice and see some of the code involved with that. So as I mentioned, there are three options I'm going to be talking about today. The first one is what I'm calling the virtual class option. And essentially here, we're going to have a virtual class whose methods we'll be able to override. We're going to have a constructor that's going to kind of kick things off for us. We're going to have an enum consisting of trigger contexts. So that'll be your before insert, before update, after insert, things like that. We're going to call a method called setTriggerContext to let our framework basically make our framework become aware of what context it's running in. So that's going to be the routing part for us. We're going to see a bunch of virtual methods that we can override. And we're going to see a run method that's going to take a look at the trigger context we're in and basically send us to the right spot in our code to execute the business logic. And so this code is essentially going to start in our lead trigger, just like we did before. It's going to go to our lead trigger handler, which is then going to call our framework, which is going to be a single trigger handler class. The trigger handler is then going to reroute us back to our lead trigger handler where our processing will take place. And so let's take a look at what that looks like. So I'm going to jump back into my code here. And I'm going to comment out my trigger handler for a second. And I'm going to uncomment out a different version. So let's get rid of all this. And now we have this.
Sorry to interrupt you, Adam. Can you put the VS Code in the full screen mode?
Yeah, I was going to in a second. I was just making the code changes first, and then I can make it a little bit bigger.
Okay.
Let me just finish commenting this out, and then I will make the code easier to see. Okay. Hopefully that all saved now. And I'll open this also. Okay. So let me make this bigger now. Okay. All right, hopefully that's a little bit easier to see. So now I've taken my trigger, and we started with 30 lines for before insert. And we changed it to 30 lines for the entire trigger that we will never have to edit again, hopefully. And now I've gone down, I've changed it to 1 line that we will hopefully never have to change. And this is going to be calling our framework. So all my trigger is doing now is simply instantiating a new instance of our lead trigger handler and calling the .run method. So if we look at our lead trigger handler, we see we're going to extend our framework here called trigger handler. And all I've done here in the lead trigger handler is not really too much. The code itself is the same. We're doing some stuff over leads, we're checking for accounts, we're inserting our cases, so that's all the same. One thing you may notice, I don't have to pass in trigger.new anymore. Instead, I have a constructor that is basically taking trigger.new and casting it to a list of leads. Because our framework works on all objects, we just have to tell the framework which objects we're working with in any particular time. So trigger handler will handle all of the trigger.new stuff. We just have to remind it, hey, just a heads up, I'm in the lead trigger. Trigger.new is a list of leads. And then by extending trigger handler here, we're going to trigger this constructor. And the constructor is going to call the set trigger context method. And again, that's essentially going to be our routing piece. So if we look at set trigger context, that's just calling another method called set trigger context with an optional boolean for test mode.
We are not able to see the code properly. Some of your screen is stuck. Can you try to put it on a full screen mode or something, or like we're not able
Sure.
to see it properly?
Okay, what are you seeing right now out of curiosity?
Right now, some if else is coming, but that is partially visible.
Oh, really? Okay. Let me try full screen mode.
Yeah, now we can see your full code.
Yes.
Okay. I can try this. Okay. Okay. Is that a little bit better?
Much better.
Okay. All right. All right. So anyway, our so I'm going to get back to the other class here, but the lead trigger handler is going to call the constructor of trigger handler, and that's going to set our trigger context, and so that's essentially going to be our routing piece. So set trigger context, we'll call this other set trigger context with an optional mode for test mode if we want to do something specific in our testing. And essentially, it'll be doing all that routing piece for us. So it'll be doing the trigger before, trigger is insert, trigger is after, trigger is insert. But the difference here versus before is we only have to write this code once. And we can use it for any object. We don't have to put it in every single trigger. We just leave it in the framework. We leave it alone. And all of our triggers can therefore use it without us ever having to worry about it anymore. All of these contexts here just come from this enum on the bottom with all the different event types. And we're going to end up basically telling our trigger framework what context are we running in. We can then go back up here. If you remember when we fired our lead trigger, we fired the lead trigger handler.run method. And so if I go back into our trigger handler now, we go to our run method here. We know what our context is because we just set it. So in our case, we're going to worry about the before insert context. And then in our run method, we're going to see that because the context is before insert, we want to call this dot before insert. And in our case, this is referring to the instance of trigger handler that's running, which is our lead trigger handler. And so we're going to fire the before insert method. The other thing to note, this is a virtual class with a bunch of different virtual methods. So we have a virtual method essentially for every event type. And that allows us the ability to pick and choose the ones we want. So in our case, if I go back to lead trigger handler, we are overriding before insert, so that's fine. When we call this dot before insert, we'll call this method right here in our lead trigger handler before insert. And as you can see, that's the actual end of the trigger handler. It's just this one method. And so because of that, that's the only method we're overriding. If I were to call any of these other methods, I don't have to implement them. I don't have to think about them because they're already existing in the framework. And so essentially for after insert, for example, we'll come down here because we didn't override it. We'll see that it's empty, and then we'll exit. And that'll be the end of our trigger execution. And so this gives me the ability to kind of pick and choose what methods I want. I don't have to worry about the routing. I don't have to worry about implementing all of the methods. I can just pick the ones that I have to use for my trigger. And so let's go see this in action now. So if I go exit presentation mode and go into Salesforce. All right, so I have a lead here I want to insert. We'll insert one for Captain Marvel. So I'm going to insert this lead. And if I go look at the debug logs now, see if we can put our presentation back up on the side here. I'll see that we started off in our lead trigger. We called our trigger handler constructor. We set our trigger context to before insert. We called our run method. That routed us to our lead trigger handler before insert method. It ran and it did everything it needs to do. Our trigger kept going into the after insert context. Went back to our constructor, set our trigger context, went to the run method, and because we didn't have any after insert method implemented, doesn't throw any errors, just goes to the after insert part of the framework, sees there's nothing there, and gracefully exits. And so nice, pretty straightforward, one class framework. We're able to pick and choose the methods we want and don't have to worry about the routing piece and don't have to worry about remembering to implement all of the methods. So the ERD for this is pretty simple. We create our trigger and we create our object trigger handler for each object. And the framework's going to provide that virtual trigger handler that has the run method, sets our trigger context, and can go and provide a bunch of virtual methods we can choose to override or we can choose to ignore on an object by object basis. All right, so what did we accomplish with this framework here? We saw we were able to get down to a one-line trigger, which is always great. Very easy to debug a one-line trigger. We saw in our handler, we were able to only have to add the handler methods we want to use. We don't have to add all of them if we don't want to. And we saw that all the routing was handled for us. So we, instead of setting it up in each and every trigger, we put it into the framework, and that all gets taken care of for us. We don't have to worry about it anymore. One thing we didn't talk about in this framework that we will in some of the other ones is some sort of recursion check. And that was more for simplicity's sake. If you, I'll give you the link at the end to download this framework off of GitHub, and there are some extra things in there about trigger bypasses that you can pass in. If the lead trigger framework's already running, you don't want it to run again, you can pass that in and do some checks against it. And they also give you the option to set a max loop counter. So if you only want the trigger framework for leads to run maybe once or twice in the entire transaction, you can set that, and the code will respect that as well via the framework. All right. So let's take a slightly different direction now and talk about a different framework implementing an interface. So the nature of interfaces are essentially, they give you a bunch of required methods. And if you want to implement the interface, you have to implement all of the methods. And so we'll see what that looks like in a second here. We're going to see a trigger dispatcher, again with a run method. And then we're going to see, again, our trigger handler with all of our context methods as well as an isDisabled method that'll give us the option to basically put that recursive check into place, or give us the option to shut down the triggers via the framework altogether. And so for this one, it's going to work a little bit differently, but somewhat similarly at the same time. We're going to start in our contact trigger here. The contact trigger is going to call the trigger dispatcher, which will handle the routing for us. The trigger dispatcher will then call our contact trigger handler, which is going to implement our iTrigger handler interface. And the contact trigger handler is going to basically execute the business logic. And so let's go take a look at that one now. So I'm going to jump back into IntelliJ here, and I'm going to open up the contact trigger. And let me put this into presentation mode. Okay. So we see once again here, we have a trigger on contact. Once again, nice, clean one-line trigger. And all we're doing here is we're calling our trigger dispatcher. That's part of the framework. We're calling the run method, and we're just going to give it a new instance of our contact trigger handler. So if I go open those up now, trigger dispatcher, contact trigger handler, and our iTrigger handler interface. So the interface, nothing too crazy going on in there, just our, again, all of our different event method types, before insert, before update, after insert, etc. With capabilities to pass in things like trigger.new, trigger.newMap, trigger.oldMap. And then, as I mentioned, there's another method in here called isDisabled that'll let us shut down the framework if we want to as well. And then iTrigger handler interface, we have our contact trigger handler, which implements it. And this contact trigger handler is what we are actually passing to our trigger dispatcher. And so in our contact trigger, we called the run method on our contact trigger handler, which again is an instance of our interface. And the first thing we're going to do is check, is this handler disabled? And so if I go look in our contact trigger handler, we have an isDisabled method. And so we can implement this however we want, really. But the way we're going to implement it here is it's kind of twofold. Number one, we're going to check a custom setting called trigger settings. And check for contacts to see, you know what, do we, from the Salesforce UI, just want to shut down the entire framework? And so in Salesforce, I have a custom setting here that essentially for any object, I can choose to just disable the entire framework for those objects. And with this isDisabled method, it'll respect that. So if I disable it for contact, we'll come into isDisabled here. We'll see that this is false, or we'll see that this is true rather, and this framework should be disabled, and our framework will exit gracefully without running any more code. If we choose to let the framework run, we still have an option to disable it via the static variable. So if elsewhere in my code I decide, you know what, I don't want contacts to run triggers right now, I can just set that variable to true. And again, that will dynamically, programmatically shut down the framework as well. So with our framework, we can rest assured that we're going to have some way to disable the triggers at all times. If isDisabled is false, we're going to keep going in our run method here. That's all that's in this class here, the run method. And after checking for isDisabled, all this is really doing is our routing. So again, we're checking our is before is insert, is before is update, is after is insert, etc. And we are calling the appropriate method. So we passed in our case, contact trigger handler. And so if it is before an is insert and it's not disabled, we'll call our handler before insert method. We'll come back here to our contact trigger handler, and We have a relatively small before insert method, and we're just checking to see if we included test in the last name, but this is going to run our before insert code. And the trigger framework will run again, eventually run our after insert code as well. One thing we'll notice here, all of these methods are being taken from the interface. So that means we do have to implement them. But as you can see, the ones we don't care about, we can just kind of leave blank. We will end up with some duplicate code, but at the same time, we'll know that all of our triggers are going to have all of these methods. We're not going to have to worry about a potential case where a method is missing somewhere. And it keeps our trigger dispatcher nice and clean because we can have a single run method that's going to route the same way every time for all of our triggers. And so let's take a look at this in action now as well. I'll exit presentation mode. And we'll insert a new contact now. So now we're going to insert a contact for Ironman. Execute that. And again, if I filter on our debug log, we're going to see we started off from our contact trigger. We called our trigger dispatcher. The trigger dispatcher.run method checked, is our contact trigger handler disabled? It was not, so it kept going. We called our before insert method. We then went back to our trigger in our after insert context. Again, called the run method. Again, checked if it was disabled. Called our after insert context, and then exited. And so a little bit more here, we saw two classes that the framework is giving us here in our ERD. We have the trigger dispatcher with the single run method that we shouldn't ever really have to change. And we have our interface, the iTrigger handler interface, which is going to provide all of our event methods. And it's going to allow us the ability to shut down the framework either via the UI or programmatically. And it'll be nice to know that for all of our triggers, we'll be able to turn them on and off in pretty much any way we want. And just like the first framework we saw, we have to provide the object trigger, we have to provide the object trigger handler, but the framework takes care of everything else. The main difference here being is that we now have to implement all of the interface methods in every one of our triggers. And here, once again, we had a one-line trigger, which is great. We saw all of our routing being handled for us again, which is great. The interface is going to keep all of our handlers consistent and have the same methods. And in that way, we're going to know that all of our triggers can be turned on and off the same way. And we're also going to have potentially multiple ways to deactivate a trigger. All right. So virtual classes are great. Interfaces are great. What if we wanted to get the best of both worlds and combine them? Right? If we have a very complex org, we might need a lot of different things going on. We might want to go for framework number 3 that we're going to talk about today, which is going to be a full object-oriented architecture framework. And as you can see, just based on the bullet points, it's going to be a little bit more involved than a lot of the other ones we've been talking about so far. So this one's going to have, I think, 5 classes in the framework. It's going to be 2 interfaces and 2 base classes. And the way this is going to work is we're going to have a dispatcher interface with all of our required methods we have to implement. So that's going to be all the event methods, before insert, after insert, before update, etc. But then we're going to have an abstract dispatcher base class that's going to implement the interface, but in a virtual way that will allow us to override it and pick and choose the methods we want, kind of like with framework number 1. So we'll get kind of both at the same time through the framework. We're going to also have a trigger factory class that's going to do the routing for us and basically figure out which class we need to call, which trigger handler class we need to call to get the process running. And then we're going to have another interface for our actual handler, which is going to have two methods in it, a main entry and an in-progress entry. And this goes back to the concept I was talking about at the beginning. What if we want code that kicks off the process, for example, our leads, to operate one way if it's the one that's causing the triggers to fire? But if we're inserting the cases as part of the lead process, maybe we don't necessarily want the main case trigger code to be firing. Maybe we just want a scaled down validation process for that. Or if our lead process is already running and something else kicks off the lead triggers again in the same transaction, we might want to recognize that and handle that a little bit differently than starting all of the lead triggers all over again. And so the interface will allow us to do that. Once again, from that handler interface, we're going to have another abstract handler base class that will implement the interface and allow us to override it. And the other big difference here is that we're actually going to have event-specific handlers. So whereas the first couple times we've been talking, all of our handler code was in one place. We had a lead trigger handler, a contact trigger handler. We're going to be working with accounts for this one, and we're going to have a different class for account before insert versus account after insert versus account before update. So they're all going to be their own classes. And we'll see what that'll get us as we go on here. All right, so this code's going to go on a little bit more of a journey than the previous two frameworks did. We're going to start off, once again, in our triggers, which is great. Triggers are going to be nice and clean, and they're going to call our trigger factory. And our trigger factory is then going to do kind of our routing for us and figure out, all right, where is it that we need to go, what object we're working with. And we're going to fire our account trigger dispatcher in this case, because we're working with account. Our account trigger dispatcher is going to use our trigger dispatcher base class, implementing the iTrigger dispatcher interface to figure out, all right, let's send us to the account before insert trigger handler, which is going to extend our trigger handler base, which is implementing the iTrigger handler interface. All right, so let's go see all this in action now. All right, so I'm going to start off in our account trigger again. And so once again, we see a nice clean one-line trigger. And here we're going to call our trigger factory. And so if I go into our trigger factory, if you saw, we passed it the account S object type. So basically, we're just telling our trigger factory, hey, trigger factory, we are firing some triggers on accounts. Please route us in the right direction. So our trigger factory is going to say, that's great. Thank you for telling me you're working with an account. I'm going to go figure out what trigger dispatcher we need to work with accounts. And it's going to call get trigger dispatcher down here. Get trigger dispatcher is basically going to say, all right, you're working with account. If you're working with a custom object, let's take out the __C. And we're going to figure out we need to work with the account trigger dispatcher. If we have a custom object, it might be the custom object trigger dispatcher. But either way, I want to construct a new instance of our trigger dispatcher and return it. So in our case, we're going to be working with account trigger dispatcher. And as you see here, it's going to be an instance of iTrigger dispatcher. So if I open up account trigger dispatcher, it's going to be extending this trigger dispatcher base, which, as I mentioned, is going to be implementing our iTrigger dispatcher interface. And iTrigger dispatcher is just, again, the interface is going to have all of our event methods. So it has our before insert, before update, after insert, after update, all that good stuff. We also have a couple other methods we can choose to put in here, bulk before and bulk after, in case we have any bulk actions we want to take. And we're going to have an and finally in case we want to do anything to close things out. And by implementing that interface in our base class, this base class here is going to then implement all those methods in a virtual way that we can choose to override. It's also going to have some Boolean values here we can use later if we want. And in our case, we are going to be in the account trigger dispatcher. So we can extend that. We can pick and choose. All right, I want to extend override before insert. I want to override before update. I can override all of them. I can override one of them. It's kind of up to me. But going back to our trigger factory, we figured out we need to use account trigger dispatcher. That's great. We see that it's an instance of iTrigger dispatcher. If for whatever reason we don't have a trigger dispatcher for that object, again, that's fine. We'll be able to catch it in our trigger factory, throw an error message, letting us know we need to create one. But if not, we're going to call the execute method on account trigger dispatcher. So we're going to come down here. We're going to set some trigger parameters, which is essentially just a wrapper object to hold trigger.old, trigger.new, and all of our trigger contexts. And then we're going to do our routing, just like we've seen in all the other frameworks. So if it's before, we start off with our bulk before method. Before insert, we call our insert method. Before update, we call our before update method, and so on. And so in our case, we want to call account trigger dispatcher dot before insert. So our trigger factory found the dispatcher, figured out where to route us, and now we can go into account trigger dispatcher before insert. All right, so now we're in our before insert method. And again, we're doing some sort of recursive check here. So basically, we're checking to see, is this before insert method already running as part of this transaction? Did we call it a second time? If it's not already running, great. Let's tell the framework we want to run it and execute our execute method. If we're already running, that's fine. We're going to call the same execute method, but instead of passing a new instance of our account before insert trigger handler, we're going to pass a null. We'll see what that looks like in a minute. But as you see here, our before insert method is calling the before insert handler. The before update method is calling the before update handler. The after insert method is calling the after insert handler, and so on. All right, so we did our routing. We're in our before insert for our dispatcher, and we're figuring out, all right, do we want to pass in an instance of the before insert handler, or do we want to pass in null, this execute method? And this execute method is going to be part of this trigger dispatcher base class. So if I go back in there, our execute method is basically just going to say, okay, you passed in a trigger event. Forgot to point that out. But here we're passing in before insert. In our before update method, we're passing in before update. After insert, we're passing in after insert, and so on. So we choose maybe not pass in a handler instance, and we choose to pass in our event. And then we basically say, okay, did you pass in some sort of handler instance? If you did, we're going to set some variables here to the handler instance that you passed in. And if we're not already in that context, so if this is the first time our account before insert is running in this transaction, we're going to call the main entry of our handler instance. If account before insert is already running and starts running again, we're going to, in that case, call the in progress entry method of our before insert handler. And again, that's going to give us the option to choose, do we want to run the same code? Do we want to run different code if this code is already running as part of the same transaction? Or potentially we can configure it a way that says, is this the code that kicked off the process or not? Maybe we want to run some different code for that as well. So we have that option as part of our framework. In our case, though, we have our account before insert handler, and we're calling our main entry method. And so if I open up the account before insert trigger handler, we're going to extend trigger handler base, and we're going to implement iTrigger handler. And so iTrigger handler, again, an interface, main entry and progress entry. It also has another method for updating objects that we can use. And then trigger handler base, once again, is going to implement that interface and allow us to extend it virtually. And so it has some methods here, main entry and in progress entry, again, implementing the interface. And then if we go back to our handler, we can override main entry to just do the things that we want. And in this case, we're going to ignore the in progress entry. And the framework's going to kind of handle that on its own. And so the code itself isn't actually doing anything that interesting, just checking for the word test in our name. But we basically got here through a very, very long journey. But at the same time, once the framework is in place and we understand it, all we have to do is create the classes for the events that we want. And we can go right away to implementing the main entry method and putting our logic in there without having to worry about the routing, without having to worry about are the dispatchers there or not, because the framework will detect if it's not. And it'll handle, is this the first time you're running, or are we in the middle of a recursive state? All right, so let's go run this and kind of follow along here. As you can see, looks like it closed out of a bunch of them, but there were quite a few classes we ended up opening in that context there. So I'm going to go insert a new Marvel account here and see if we can follow along in our code journey at the same time. But if I execute this now, we started off with our account trigger running. We went over to our trigger factory. We created the instance, or we went to our create trigger dispatcher and found the instance of our account trigger dispatcher. We then did the routing and ran the execute method of the trigger factory. And that sent us to the account trigger dispatcher base. It sent us to account trigger dispatcher before insert, which sent us to our trigger dispatcher base execute method, which eventually sent us to our account before insert trigger handler main entry method. We then did the same thing here, starting with our account trigger, went to the factory, went to the account trigger dispatcher, went to our trigger dispatcher base, and eventually ended up in our account after insert trigger main entry method. So quite a few things going on in there. And if we look at the ERD for this, obviously a little bit more complex than the previous ones. And we see we have 5 different classes provided by the framework here. So 2 interfaces, 2 base classes, and our factory. So we had the dispatcher interface that had all of our event methods, before insert, after insert, before update, after update, etc. We had our base class that implemented the interface that we were able to extend in our object trigger dispatcher that we had to provide. We had the trigger factory that did all the routing for us and found the trigger dispatcher we needed based on the name. And then our trigger dispatcher was able to use the event classes, so account before insert handler, account after insert handler, etc., utilizing our trigger handler base class to extend it or implemented our iTrigger handler interface. And so that whole part of the framework just had the main entry and in progress entry that allowed us to choose what part of the code we're in, what context we're in, and potentially send us to a different path. And then the other thing we need to provide were all of the individual event methods. We can pick and choose which ones we need to implement based on what events we want to work with. One other thing we didn't actually see, but we see here in the ERD is that file in yellow. So we talked about at the beginning, one of the benefits of trigger handlers in general is the ability to reuse code by putting everything out of the trigger and into discrete methods in a single file. because we're splitting up all those files into individual event classes, we still may want to reuse some of the code. And in that case, we can potentially create one additional class, the account helper, or any object helper, to have some of those kind of utility methods that we want to use across different parts of the code. So we'll still be able to take advantage of that as part of the framework, but it'll allow us to separate all of our event code into specific classes. All right, so what did all of this get us? So once again, we saw a one-line trigger. We saw that all of the routing was being handled for us. We kind of had the best of both worlds here, where we were able to establish all of our methods through the framework, but still let us pick and choose which ones we wanted to implement for any particular object. The other thing we saw here were individual event handler methods. So if you think about a pretty complex org, we had a somewhat straightforward use case at the very beginning in our lead trigger, and it ended up being 30 lines just for before insert. And we talked about potentially expanding that before insert functionality. So we may go up to 50 lines, 75 lines, even 100 lines in our before insert. If we start taking that same approach for all the other events, after insert, before update, after update, pretty soon we end up with a 500-line trigger handler, which once again can be difficult to test, difficult to maintain, et cetera, especially if we start adding some additional methods for reusability. So by splitting it out, we can keep our classes a little bit smaller, potentially less complex. We could have maybe a before insert handler that's 100 lines long. We can have a before update handler that's 100 lines long. Each can be tested individually. Each can be still easily called by the framework. And we don't end up with any classes that are a little overwhelming to look at, overwhelming to test, and a little bit harder to maintain. All right. So let's talk about kind of some of the different approaches and things they have in common and where they differ. So we saw in all of them, we were able to consolidate our triggers down to a single line, which is awesome. Simple triggers are always better. We saw all the frameworks were handling the routing for us. And so we do need to implement it once, but once it's there, we don't have to worry about it anymore. We can focus on, in the first two, focusing on the individual handler methods, and in the last one, focusing on the main entry method in our event class handler. We didn't see it in the first approach, but we definitely can implement some sort of recursive check in all three of them, making sure that we're not running the same code multiple times in the context of a single transaction. Or if we are, we're maybe handling it a little bit differently. We can also potentially build into the framework a way to just turn off part of the framework altogether, either via the UI or programmatically. With the virtual approach and the architecture that combined the virtual and interface approaches, we were able to kind of pick and choose which events we want to implement. Whereas with the interface, you kind of have to implement everything at once. Again, the benefit of being able to pick your events is you don't end up with any unused code. The downside is now you have to be adding new methods to your handlers, or in the case of our architecture, be adding new classes. So pros and cons, depending on what works for you and your team. And the other thing, I guess the next one, we saw in our architecture, we were looking for a class that had a very specific name. So the class had to be named Account Trigger Dispatcher, or the framework wasn't going to be able to find it. And this is, I always find naming conventions is one of those things, when I first hear about it, I'm upset. And then later on, when something isn't named properly, I also get upset. And so it is a little bit of overhead at the beginning. But at the same time, if I know everything is named the same way, I don't have to worry about figuring out how somebody chose to name the functionality for account, how somebody chose to name the functionality for lead. I know everything's going to be named the same every time, and it'll save me that time and energy into figuring out how to find the class where my trigger logic lies. So sometimes naming conventions can be a good thing, but just something to keep in mind depending on how your team is structured. The other thing we saw, we spent probably twice as much time talking about the third framework as we did the first two, and that's because that has a lot more overhead to it, a lot more jumping around. And again, could be a good thing or a bad thing depending on the size of your org, how your org is structured, and things like that. So with the virtual interface or the virtual approach, we saw just a single file as part of the framework. For the interface approach, we saw 2 files as part of the framework. And the architecture approach saw, I believe, 5 files as part of the framework, with a bunch of different individual files for the events. And again, it can be nice to get up and running with just a single file handling all the routing for you. Could be nice to have maybe a couple different files doing the routing and doing the method implementations. But sometimes your code and org is very complex, and you maybe need that additional structure in place in that architecture type framework that might take a little bit more to get up and running. But once it's there, you can really focus on the nitty-gritty details in my specific class and my specific type of execution of a before insert operation, focusing on what that logic looks like instead of worrying about how things are being routed, how things are going to be working for any particular object. So we kind of already touched on this, but I'll go through them again. Some of the drawbacks. I'll stress again that no framework is perfect. And as we saw with our architecture framework, we also have the option to kind of mix and match principles that we want to use and concepts that we don't. With the first two, the virtual and the interface capabilities, we kind of leave ourselves open to extra large handlers if our orgs are very complex. And then with the interface method, we saw that we have to implement all methods all the time and potentially leaving us with some unused code. Again, it could be a good thing if we always see that the methods are there, so we know exactly where to go to start implementing them. Don't have to remember what they're named in the interface because they're already there when you create the class. But at the same time, it ends up with unused code. So kind of a pro and con there. With the architecture, again, naming conventions is, again, one of those things. Could be good, could be bad. But we do have some specific naming conventions, and you can kind of edit the framework to change that however you want to name your dispatchers. But the architecture is generally going to enforce some sort of naming convention. And that's both for your benefit and easy use for the framework to find what dispatcher you need. Theoretically, if you really wanted to, you could put the names in a custom setting or custom metadata and give yourselves a little more flexibility with some of the naming as well. But then again, if everything's named a little bit differently, it might be a little bit harder to find where things are happening. With the architecture, we also saw some code overhead. So I think we can get up to about 15 files for a single object that we're interacting with at any point in time. So there is going to be more of a learning curve with that one. But once we kind of understand how that routing is working, we can get down to the real nitty-gritty details of, all right, I want to troubleshoot the in-progress entry method of my after update context for account. We're going to be able to find that relatively easily once we understand how the framework works and operates, and we can be very specific in controlling how our code is working. All right. So kind of summary and some final thoughts that I have. As we saw, we can kind of mix and match strategies. No one framework is perfect. So if you want to override some methods, you can do that. If you want to implement an interface, you can do that. If you want to do both, you can do that. I generally recommend some sort of recursion check, either via Salesforce UI, programmatically, both. It also helps when testing, if you can turn off some triggers that don't necessarily impact what you're doing. Maybe I want to turn off my case triggers if I was testing that initial lead trigger functionality. So ultimately, pick the strategies and pick the concepts that make the most sense for your org. One thing I will note, and might be kind of obvious, I was able to install all of these into a nice plain vanilla developer org and get up and running right away. That may not be the case for the org that you're working on. So these things generally are easier to implement at an org's beginning rather than later on, but at the same time, There's definitely a lot of benefit from implementing things kind of as you're going as well, or building new triggers, maybe start using the framework for some of those and editing some of the other ones to be built into it later. I know I've definitely thought to myself, wouldn't it be nice if I could just shut this trigger functionality off temporarily? Or trigger maybe is named something odd and I have to spend a few minutes trying to find it. Also not a great feeling either. And again, I want to reiterate that no one framework is perfect. There are pros and cons to all aspects of all the frameworks. So again, I'm going to provide some links that you can download the code for all three of these. But I'd recommend you take a look at them, pick and choose the concepts you like, and maybe think about how your orgs could start using them, or maybe some principles you want to think about that might make your life easier down the road. All right. So if you're interested in my initial trigger code, it's not that interesting necessarily, but I have it at bit.ly/lead trigger. If you're interested in my initial handler we walked through, you can get the handler at bit.ly/lead handler, and the updated trigger code that we changed at bit.ly/lead trigger final. And probably the most interesting part's the actual framework code. So the first framework, the virtual one, is completely downloadable via an unmanaged package from GitHub, bit.ly/virtual trigger framework. So you can get the code involved with that. The interface trigger framework is bit.ly/interface trigger framework, and I don't think that one actually has a downloadable link, but they have all of the code on that page to be able to copy and paste it into your org. And again, it's only the 2 files, so hopefully shouldn't be too much there. And then there's a link that talks about the architecture trigger framework, as well as a link to an unmanaged package for that one as well. And you can get that at bit.ly/arch trigger framework. Right. And so with that, thank you so much for having me today. Again, feel free to check me out on Twitter or my blog. And I thank you all for coming to Apex Hours. I'll turn it back over to Amit.
Yeah, thank you so much, Adam. It's a great learning for everyone. And I can see a couple of questions on the chat window. So would you like to open the chat window and answer that?
Sure. Let me see. Let me exit presentation mode here. Okay. Chat. All right. So it'll be recorded. So text editor, I was using IntelliJ with the Illuminated Cloud plugin. So just a plugin on top of IntelliJ for Salesforce. Kind of screen, okay. Sorry about the screen issues. Yeah, so the trigger classes, as I mentioned, I have some links in here, and I think this presentation can be made available, and it'll be on YouTube as well with all those links. There's only one method before insert. Create multiple sub-methods. How do we implement it in Framework 2? There's only one method in the before insert for Framework 2. So if I open that one, that was contact. So let me see here. So there's only one method in before insert. Usually we create multiple sub-methods. How do we do it in Framework 2? Yeah, so basically the framework in this case is going to call the before insert method. And then from there, you can choose to route it however you want. So you can potentially have separate methods for before insert that you call either from the same trigger handler, from helper class. If you want to have separate like main entry methods and progress entry methods, you can have that as well. How will trigger context variables get passed? So I think they get passed differently in each of the frameworks. In one of them, we had the lead trigger handler where we weren't actually passing any sort of variables, but rather, because we're in our trigger instance, we have access to trigger.new. And because we know we're in the lead trigger handler, we can cast everything to lead. So if we were to add, right now we just have before insert, but if we start adding before update, before delete, after delete, we're going to expand our constructor here. Potentially add another list of leads for old leads for trigger.old. Potentially add some maps for old map and new map. We just cast them as class variables, and then we can use them in the trigger here. The contact trigger handler, I believe via the interface, we always pass in trigger.new and trigger.new map and old map. And then again, we do need to do our casting in the middle of that method. Just to remind it, hey, we're working with contacts here in our contact trigger handler. And then in the architecture framework, we have a class called trigger parameters that we constructed in our trigger factory that was essentially giving trigger.new, trigger.old, and assigning it to old list, new list, old map, and new map. So if I go back to our trigger factory, we basically constructed those trigger parameters. And then when we called our before insert, before update, etc. methods, we passed in those trigger parameters. And so if I go to our account trigger dispatcher, we'll see we take those trigger parameters, and again, we passed them to our class method here. So account before insert trigger handler. Again, we pass in those trigger parameters, and then we can say, all right, tp.newList, tp.newMap. Again, we do the casting here. But again, the framework, for the most part, is handling all the trigger variables for us. The only thing we have to do is cast it for our respective triggers. Right. Anybody with any more questions for now?
Hi, Adam. That was a very wonderful presentation. Thank you for that. I just have a couple of questions, if I may go ahead and ask.
Sure.
So on the interface trigger framework, I know you showed you showed how to disable the trigger, both through the code as well as through a custom setting. So assume the same is possible with the architecture trigger framework as well.
Yeah. So the architecture trigger framework, you can definitely include an is disabled method like we had here. That's probably my favorite way to do it, is either via the UI or via a static variable. They had one in there as well for, if I can find where it was, they kind of had something similar where they were checking to see, is this already running, essentially? So we set it to true, and then we execute it, and then once it finishes, we set it to false. So if it's already executing and we come back to this block in the code, we're going to be executing our in progress entry method. So it kind of handles it that way, and if we choose to ignore the in progress entry, then it'll essentially not do anything for that second time it runs. But we can definitely either extend our interface to have like an is disabled method, or we can choose to put that in trigger by trigger, depending on what our preference is.
Okay, got you. And my other question is, obviously the architecture trigger framework seems many orders of magnitude complex compared to the virtual one, or sorry, compared to the interface one. So what would be like a compelling reason to use the architecture trigger framework? Like, one thing that I understand is it can detect when the trigger is actually processing, which is not possible with the interface trigger framework. Is that correct?
I don't know if it's maybe not possible with the interface trigger framework, because we can probably implement something similar if we wanted to do some sort of, set some sort of flag, kind of like we're doing here, to maybe call different methods. I think the difference there is it allows for more detail. So in the interface trigger framework, we're essentially saying, are you calling before insert? Great. All of the before insert code is going to be here. Whereas with the architecture trigger framework, instead of having a single method for before insert, we're going to have its own class, and we're going to have different methods for main entry and in progress entry. So it's generally, if your org is very robust and you're having hundreds of lines of code for each instance, you're not necessarily going to want a 200-line before insert method. You might want to put that into its own class, and you might want to more closely target main entry code is here, in progress entry code is here. So it kind of, if your org is less complex, or you don't necessarily need to worry about having different behavior for the different contexts you're in, I would recommend less overhead. But that just kind of gives you more granularity in being able to control the different behavior for the different possibilities and paths that your code can take.
Oh, okay, got it. Okay, yeah. Thank you.
Yeah, sure. Virtual trigger framework is not the same virtual class you use in the presentation. Can you share what you use in the presentation with the lead trigger implementation? I thought it was. Let me go double check that really quick. I think. So if I go into GitHub here, I think I might have skipped some of the methods, but it should be otherwise. If I go into classes, trigger handler. So yeah, so we have the run method. We have the trigger context methods. I guess I did change mine a little bit, actually. So there's some extra stuff in here to validate with a loop counter, validating that it's running, getting the handler name. I think I might have this. Let me go find the links for that really quick. Where did I put that? Simple. Okay. No, that's not it either. Okay. So I have that, I guess, and I can put that in the presentation. Also, bit.ly/trigger handler should be the trigger handler for the virtual class that I was using. Yeah. I didn't realize I took out a bunch of stuff. Yeah, so there's some more stuff in there if you want to look at it, but if you want just the scaled down version I used, I can provide the link to that in the presentation as well, bit.ly/trigger handler. Any more questions for today?
Thank you, Adam. That's a really great session, and thank you everyone for the joining us, and thank you, Adam. So, and don't forget to sign up our next session that is on asynchronous process. So join that to learn all about batch job, future method, queuable job, and platform events. Thank you everyone, and thank you, special thank for you, Adam. Thank you so much.
My pleasure. Thanks so much for having me. Thanks everyone.
Thank you everyone.
Thanks, Adam. Thanks, everyone.